Hello everybody, and welcome back to Coding with Mock. In this video series, we will be talking about multithreading in Java, or how we can accomplish multiple tasks at the same time within one Java application. Okay, now before we start explaining how to do multithreading, we first have to learn a few new words. Now, these words are multitasking and tasks, multithreading and threads, concurrency, and parallelism. Okay. Now, multitasking or multiprocessing should be something you are already familiar with. Multitasking is when you have multiple programs open on your desktop at the same time, as you can see here. And just like on your desktop, on a server, multiple applications can be run at the same time. Same thing, right? For example, on your desktop, you probably have an instance of IntelliJ open and maybe a web browser at the same time. And you can be coding in IntelliJ while YouTube is playing at the background at the same time. This is called multitasking. And the different applications within multitasking are called tasks or processes, right? Now, multithreading is when one application is doing multiple things at the same time. You could program an application to check for emails and at the same time calculate pi to 100 decimals in the background. Now, you could be asking yourself, now what is exactly the difference between multitasking and multithreading? That's a good question. Now, the difference between those two is in the memory space. The memory space for a multi-threaded application is different for multitasking applications. Okay. Now, if we look at multitasking, when two applications are running on your computer, or three applications, as you can see in this graph, are running on your computer, they don't share memory with each other, right? When an application starts, it asks the operating system to reserve some memory space, and then the operating system will then portion a little memory to the application, and under normal circumstances, applications will not interfere with each other's memory. It is possible in some programming languages to mess with the memory space of another program, but you would have to explicitly start working with memory addresses, and that's something that is not even possible in Java. Okay. But the thing to remember is multitasking, every application has its own memory space. Now, in multi-threading, we're doing all that within one program. The program is doing multiple things at the same time within itself. So as far as the operating system and the memory is concerned, there is only one program running. And so the memory is shared between the different threads. Okay, so that's the difference between multitasking and multi-threading. There's a lot more differences, but this is the difference that we as developers should care about. Okay, multitasking has separate memory space. Multi-threading has shared memory space. You might ask yourself, why do I need multi-threading? Now, if I have two tasks or things I need to do or I need done in my application, can't I just run them sequentially and avoid all the possible problems? That is a possibility, but some tasks can take a long time to finish. For instance, analysis of a human genome or calculating pi to 100 decimal places. Some tasks may never finish. For example, checking email. One minute you may have no emails, but the next minute you might have a new email, and then you might have missed it if that task doesn't continue to run. And if you combine these two long-running tasks or if you combine these long-running tasks with a user interface, which most applications will have in one way or another, this could impact the performance, but especially the responsiveness of your application, right? So if I have a really long, hard task and my user clicks, I don't want my user to wait 2, 3 seconds, maybe even minutes before my application responds. If a user has to wait 1 minute for an application to respond, it's gonna think that the application isn't running anymore or isn't running correctly, while it's just finishing up one task, and then after that task it'll handle your input. Something we want to avoid, right? Another reason, especially in this day and age, CPUs have multiple cores, even multiple threads per core, right? Now, back in the day, we only had one CPU and one CPU core, but nowadays we have AMD EPYC CPUs with 64 cores and 128 possible threads. I don't know about you, but as a programmer, I want those cores. I want all the cores, right? Okay. Back on topic. Now, within the subject of multithreading, we have another subdivision of which we will be handling in one of the video series, namely concurrency and parallelism. I'll explain the difference briefly, but if you can't place these things just yet, don't worry. They will start making sense later on in the course. Okay. Now, concurrency is when one or two tasks, completely different tasks, are working at the same time. Parallelism is when I divide one task over multiple threads. Okay, that's the difference. Now, this might not make too much sense for everybody at this moment in time. Rest assured, this will be explained later on in the course. Okay, so in the next videos, we will be looking at the following subject. We will first start creating and starting threads. Then we'll look at the thread lifecycle. We'll learn how to manage our threads. Then we'll be looking in one of the most important things about multithreading, especially for you guys as junior developers. We'll be looking at concurrency problems and solving concurrency problems. And then lastly, very quickly, we'll have a quick look at parallelism, why it's not concurrency, and why we don't have as many issues with parallelism as opposed to concurrency. Okay, well, see you in the next video, and we'll be starting creating our threads there. Wow.